Hello students, myself Professor Ankur. I welcome all for the gate sum session from analog circuits. We are going to have sum session 2 from the topic of diode. So let's go for the sum session. So we are having a question now from the gate 2020 ECE paper for 1 mark. The question says, in the circuitry shown below, all the components are ideal and the input voltage is sinusoidal. The magnitude of steady state output VO rounded off to 2 decimal places is dash volts. So we have a figure here. If you observe the figure carefully, there are 2 diodes and 2 capacitors, C1 and C2, each of 0.1 microfarad, and the 2 diodes notified by D1 and D2. The input voltage is 230 volt RMS. Now, if you observe the question carefully and the diagram carefully, the diagram is analogous to the diagram of a voltage doubler, where the first capacitor will charge to a value of Vm and the second capacitor will charge to a value of 2 Vm. Implies the voltage across the capacitor C2 will have a voltage value of twice of Vm. Now, since your input is 230 volt RMS, the Vm value will be root 2 times the Vrms value. So it is 230 root 2. And now, when I get the output as twice of Vm, the final value will be 2 root 2 times 230. On solving, you will get 650.538 volts. So the answer is 650.54 volts because we are having a round off of 2 decimal places. Next question. This question is from the GATE 2020 instrumentation paper. So the question is, if the diodes in the circuitry shown are ideal and breakdown voltage Vz of the Zener diode is 5 volt, the power dissipated in 100 ohm resistor in watts is option A 0, option B 1, option C 20 by 100, and option D 225 by 100. Now, if you look at the figure carefully, the figure says that we are going to have an input source of 10 sine 100 pi t volts, a Zener diode represented by Vz, and a battery of 5 volt, 2 resistances of 50 ohm and 100 ohm, and a diode. Now, we need to understand the situations of both the diode because the input is given as 10 sine 100 pi t. So the peak value of the input is going till 10. So first of all, the reverse breakdown voltage of the Zener is being given as 5. And since the diode is ideal, the anode, if it is greater than cathode, it will work like a closed switch. Else, it will work like an open switch. So we are going for a solution. So initially, we are assuming both the diodes are in the off state. So if both the diodes are in the off state, the center node will go to straight away 5 volt. So automatically, if you comment on the input and the situation of diode, we can easily say that till the time the input is less than 5, the diode will be remaining in the off state. But as soon as the input crosses 5 volt, the diode D will be in the on state. So since the diode will become on, it will work like a closed switch. So under that situation, your diode will be on. But what about the Zener? The Zener will face a breakdown. And since it is facing a breakdown, because the input has crossed the value of 5, the Zener will maintain a voltage value of 5 volt. So now when I look at the situation of the 100 ohm resistor, the left side is at 5 volt and the right side is also at 5 volt. So resultant equipotential points will give me 0 current in 100 ohm resistor. Hence, the current is going to be 0. So if the current is 0, the dissipated value or the power dissipation will also go to 0. And hence, your option A, 0 watt is the correct answer. GATE 2020 instrumentation paper. So this question is for 2 marks. It's an interesting question. The question says, assume the diodes in the circuitry shown as ideal. The current Ix flowing through the 3 kilo ohm resistor in milliampere rounded off to 1 decimal place is. So we are given a circuitry here. So there are 3 diodes and 2 diodes, 3 diodes on the right hand side and 2 diodes on the left hand side. The potentials are 15 volt, 10 volt and 5 volt and 12 volt and 6 volt on the left hand side. So the 3 kilo ohm resistor is somewhere in the center. So now let's go for the solution. Now before we actually start with the solution, we have to go for small notations. The diodes can be notified as D1, D2, D3, T4 and D5. And the nodes P and Q are actually the nodes for the 3 kilo ohm resistor. So now if I look at the right hand side of the figure, the right hand side of the figure is having 3 voltages, 15 volt, 10 volt and 5 volt. So if I just assume that all of them will be on, so eventually you will find that the node Q will go to 15 volt. So since node Q will go to 15 volt, the remaining 2 diodes D4 and D5 will automatically go in the off state, because for them anode will be less than cathode. So eventually out of the 3 diodes which are present, D3, D4 and D5, we landed up with only D3 and the 15 volt battery. So the circuit can be modified something like this. So we are having a 15 volt battery now, followed by the 3 kilo ohm resistor, and then we are having the node Q. Now you can see the diode D1 and D2. So I am supposed to find now the voltage of the node Q. That will help me in interpreting whether both the diodes D1 and D2 are on or off, or either of them is on. So I'm going for a small understanding with an assumption that both of them are actually in the on state. So I will apply KCL at node P. So when I apply the KCL at node P, I will get Vp minus 15 by 3K plus Vp minus 6 by 2 kilo plus Vp minus 12 by 2 kilo. On solving, we are getting the value of Vp as 10.5. So if Vp is 10.5, implies the diode D1 will be in the reverse bias state, because the anode potential is less than cathode. The cathode is holding at 12 volt. So eventually the diode D1 will get eliminated and we are left out with diode D2. So we are having a single path which starts from 6 volt and terminates at point Q. So if I just apply the logic of KVL and I try to find the value of Ix, I can easily say that the value of Ix can be 15 volt minus 6 volt divided by 5K. So the value is 1.8 milliampere. So the answer is 1.8 milliampere.